Many public and private organizations worldwide provide open data they create as part of their daily processes. This open data can be used and reused without any restrictions and is provided free of charge. Examples are manifold and include the mapping data of many countries, transportation data and statistical data. Ideally, open data is provided and used in cyclical, sustainable, demand-driven environments oriented around agents that are mutually interdependent in the creation and delivery of value from open data. This is what we refer to as open data ecosystems.
One could argue that current open data ecosystems are supplier-driven, exclusively building on government data, and are linear, which means that the users of the open government data do not deliver value back to the open data ecosystem. The current situation results in some value, but there is much more potential. This potential will be lifted if an open data ecosystem becomes user-driven, inclusive and circular. Value creation will be maximized and the sustainability of the ecosystem promoted. This was the underlying reasoning of the ODECO project. During the course of the project, we developed new insights that resulted in a more nuanced and complete view on open data ecosystems.
Let us start with the first pillar, from supplier-driven to user-driven. We argued that an open data ecosystem should move away from a provider-driven system towards a user-driven open data ecosystem. At a first glance, one may easily agree, users should be taken seriously by data providers. However, one should bear in mind that most, if not all data, has been collected for or with a purpose. At least for open government data, the data is collected to serve a public task. Be it a map for military purposes or the value of real property for taxation purposes. In these instances, there has been and is a close interaction between the provider and the user of the data. But after opening the data as open data, the user community expanded, resulting in an overwhelming number of new users and new user types. With this, the direct connection with these new users became much more loose or even disappeared. With, as a result, what is now generally considered a provider-driven ecosystem. So the success by attracting these new users is the explanation of the current lack of user involvement. Building on the definition of the EU Open Data Directive and the term reuse, we may argue that open data ecosystems should not only be user, but also reuser driven.
Then the second pillar, towards an inclusive open data ecosystem. The sustainability of an open data ecosystem also depends on how inclusive the ecosystem is. Initially, we argued that an inclusive open data ecosystem is an ecosystem that not only includes open government data, but also open data from other actors. Also here we developed new insights. In the ODECO project, we found that inclusivity is going beyond non-government actors providing open data. Non-government actors also participate in the open data ecosystem in many different ways and roles. For example, by hosting a platform that provides access to open data, or by organizing hackathons, or by developing teaching material on open data. Of course, these are examples and you may not find them in all open data ecosystems, but the concept of inclusivity entails much more than allowing or stimulating non-government actors to contribute their data as open data. Another insight we developed is that inclusivity should also concern the content of datasets themselves. These might not present the full picture, for example by deliberately excluding certain groups or topics in the data.
Finally, we discussed the third pillar, towards a circular open data ecosystem. In the ODECO project, circularity is reached when users of open government data improve that data and provide the new data back to the ecosystem as open data. To ensure a fair distribution of value among data providers, reusers and other actors. We found that circularity is much more than only providing improved open government data back to the system. Non-government actors may also contribute value by providing newly developed services for the open government data, or developing training material on how to use the open government data, or by providing feedback on the fit for purposes of the open government data. In many other ways, non-government actors contribute to the circularity of the open data ecosystem. You may see the connection or even overlap with the inclusivity pillar.
Finally, the concept of a sustainable open data ecosystem. We stated that if an open data ecosystem is user-driven, inclusive and circular, then it would be sustainable. However, also sustainability has multiple dimensions: economic, environmental and social. The fair distribution of economic value is already a complex puzzle. adding the environmental and social dimensions makes it a wicked challenge that calls for future research endeavors.
We shared new insights on the concept of a sustainable open data ecosystem. It shows that the maturing of the concept of sustainable open data ecosystems is an ongoing process that requires our full attention.
For further reading, we refer to the following references.
Thank you very much for your attention. You are always welcome to contact us for further information.
Hello! In this video, we will look into how non-profit and non-governmental organizations can improve the user-drivenness of the open data ecosystem. A user-driven approach is one of the features of a sustainable open data ecosystem. Such an approach to open data provision implies differentiation between various types of users and their respective needs. The data needs to have value and be directly usable for the user. For example, the right type of data in the correct format. This requires a closed feedback loop between the users and the open data providers. To achieve it, open data governance and business models should be implemented using tools that provide a more active, participatory, or responsive level of open data provider involvement with users. However, the current state of open data ecosystem suggests that it is quite supply-driven and user-drivenness is not yet achieved. Let's look next into who addresses that and how. In this video, we focus on the role of non-profit and non-governmental organizations as open data intermediaries in improving the user-drivenness of the open data ecosystem. Let's first look at who non-profit organizations are in the context of the open data ecosystem. Non-profit organizations can be functionally defined as organizations aiming to serve neglected populations, expand freedom or empower people, advocate for social change, and provide services to the targeted groups without generating profits. Non-profit organizations in an open data ecosystem can act as a type of open data intermediary. Those are third-party actors who provide specialized resources and capabilities to, first, enhance the supply flow and use of open data, and/or strengthen the relationships among various open data stakeholders. As an example, we will look at a few non-profit organizations and how their role in demand-supply matching contributes to the user-drivenness of the open data ecosystem. This is based on the case studies we conducted. NGOs enabling user-drivenness, the provider side. NPOs help create spaces for users to come together with potential data providers. For example, NPOs can organize a conference or hackathon event. Creating spaces for such communication helps users access the data providers to discuss data needs in person, establishing more lasting connections. NPOs take the role of public representatives and collaborate with the different stakeholders, which means that the data provider approaches them with questions about data publishing decisions, asking if there is an interest among the users in specific data being opened. NPOs can also use their connections with open data user communities to ask them whether they envision this data being used in the projects and creating value. The feedback is then carried back to the data provider. By lobbying for the data to be open on behalf of the user groups, NPOs bring open data providers' attention to the issue. Open data user communities can come to the NPOs with a specific data request to lobby for, or the NPOs themselves might have a social issue they found from their user research. NGOs enabling user-drivenness, the user side. Many NPOs created tools for citizens to apply the Freedom of Information Act and request data of interest from the organizations themselves, thus creating a direct line of communication to address the user's needs. As mentioned, NPOs help create spaces for users to come together with open data providers. NPOs follow the current topic of social interest and social issues and can conduct user research to see which data usability they can help the users with. NPOs also use their connections with open data user communities to ask them on behalf of open data providers whether they envision the specific data being used in the projects and creating value if opened. The users themselves also come to the NPOs with their data needs to help them open the data for the project or social issue. User communities also give feedback on the questions or requests of the data provider through the NPO. In conclusion, non-profit organizations can play an instrumental role in improving the user-drivenness of the open data ecosystem. For non-governmental intermediaries to contribute in this regard, they require specific value capabilities. Capabilities are derived from the organization's resources and are the source of an organization's competitive advantage if applied to perform essential activities within the organization. First, individual competences. Understanding of open government data concepts and data literacy skills of the employees and their motivations. The organizational capabilities. The ways with which NGOs is achieving its goals, including collaboration, organizational flexibility. Open data processes. Those are open data related activities of an NGO, such as open data enhancement or advisory services. Now you know how NGOs can contribute to a user-driven open data ecosystem from user and provider sides, by creating spaces for users to come together with potential data providers, by lobbying for open data, by being a user representatives and bringing feedback from users to the data providers, by creating tools, and by providing advice for the users.
Hello, in this video, I will be talking about technical interoperability of open data. Interoperability refers to the ability of different systems, devices or applications to seamlessly exchange and use data. In the context of open data, this often involves open data portals that host and provide access to data sets. According to European Interoperability Framework, interoperability is divided into 4 layers. One key layer is the technical interoperability layer, which focuses on optimizing data utilization and exploitation by diverse stakeholders, including the public, researchers, journalists, and other open data platforms. This is achieved through the adoption of technical standards such as APIs, standardized data formats, and protocols for data exchange and integration, ensuring that data can be efficiently shared, processed, and applied across different systems, which make it in return a user-driven open data portal for diverse stakeholders. There are some key standards, principles, and best practices which are essential for ensuring consistent data exchange among open data portals. These include Open API, which focuses on creating interoperable RESTful APIs, enabling efficient interaction between systems. DCAT, Data Catalog Vocabulary, which helps describe datasets to facilitate data discovery and exchange. Linked data, which connects related data across different sources using standards like RDF, Resource Description Framework, with examples such as Wikidata. Open data portals should ideally implement linked open data for enhanced interoperability and data connectivity. W3C Data on the Web Best Practices, which provide a set of guidelines to ensure that data published on the web is discoverable, accessible, and usable by both humans and machines. These practices promote interoperability through the use of metadata, accessibility standards, and version control. FAIR principles: findable, accessible, interoperable, and reusable, which are designed to enhance the ability of data to be shared and reused across different contexts. These principles focus on ensuring that data is properly structured, described, and licensed for easy integration and use in a wide range of applications. LOVE, Linked Open Vocabularies, a collection of vocabularies used for structured data on the web. It supports interoperability by providing standardized terms and definitions that ensure consistent data representation and linking across various platforms. Portal complying with these key standards and protocols uphold the cross open data portal's technical interoperability. To illustrate the practical applications of technical interoperability in open data, we will explore the technical interoperability elements that 4 real-world examples have in common. These examples are Australia's national map, US Open Data Initiative, Open Air Quality Data Sharing, and European Data Portal. These examples highlight the effectiveness of technical interoperability in facilitating data discovery, integration, and utilization by various stakeholders. Here are the common elements across these real-world examples. Use of open data standards. All platforms leverage widely recognized open standards, for example, the KATAP, JSON, CSV, GEO, JSON, OGC standards to ensure consistency and ease of integration. APIs for data exchange. Each platform uses APIs to facilitate seamless data sharing and interaction between systems, allowing external stakeholders to access and integrate data efficiently. Metadata and schema consistency. All employ standardized metadata schemas such as the KATAP common metadata schema to ensure that datasets are consistently described, enabling easier discovery and reuse of data. Cross-region data integration. The platforms enable data exchange from multiple sources, including government agencies or international monitoring systems, ensuring interoperability across regions or institutions. Interoperability focus. The use of standardized formats ensures that data can be accessed, reused, and combined with other platforms or systems without technical barriers. The elements of technical interoperability outlined in the previous slide are made possible by several key technologies that ensure seamless data integration, interoperability, and reuse across various platforms and portals. These consists of linked open data, utilizes semantic web technologies to structure and interlink data, enabling seamless querying and integration across domains. APIs, applications programming interfaces, facilitates data exchange through RESTful APIs for scalable web services, SparkQL endpoints for querying RDF data, and direct download APIs for bulk data access. Machine readable metadata and data ensures that data and metadata are in formats that can be automatically processed by systems, improving integration and usability and interoperability across open data portals. Web 4.0 modern web represents the intelligent interconnected web driven by AI and IoT, fostering advanced data interaction and interoperability. With the advent of modern technologies and solutions, the technical interoperability of open data is evolving, and its future lies in advanced innovations such as artificial intelligence and machine learning are revolutionizing data management by automating the processes of data standardization and compliance verification. AI algorithms can automatically detect and correct inconsistencies in data formats, ensuring adherence to predefined standards. Machine learning models can continuously learn from new data and improve the accuracy of data integration tasks. These technologies also facilitate automated data integration by recognizing patterns and relationships across diverse datasets, significantly reducing the manual effort required for data preparation and harmonization. Effective global collaboration in open data requires the establishment of international standards and partnerships to ensure seamless data exchange and integration across borders. By aligning data formats, metadata, and protocols through these standards and fostering partnerships between governments and organizations, we can enhance data interoperability and drive innovation on a global scale. Intelligent databases. Interoperability of open data with intelligent databases that enable in-database intelligent decision making. These databases can integrate data and intelligent models in the same place, such as MindDB. The future success of open data relies on the ability of data portals to ensure that information is universally accessible and usable through effective interoperability. By implementing standards, protocols, and consistent metadata, these portals can facilitate seamless data exchange and integration. This will drive innovation, foster wider user engagement and enable more comprehensive and informed decision making across various sectors.
In this presentation, we will talk about open data licenses. We will discuss two questions. What are the promises of open data licenses for user-driven open data ecosystems, and what are the challenges? To understand why open data licenses are necessary, we have to start from intellectual property. While ideas and facts are free for everyone to share, creative works like books, artistic creations, and data sets are the intellectual property of the creator. In the European Union, a data set can receive two types of intellectual property protections. One, the structure of a data set can be protected under copyright, and two, its contents can be protected under the sui generis right. These intellectual property rights limit how existing data and information can be compiled into a data set, as well as how a data set can be further reused. Intellectual property rules create a producer-driven data ecosystem, where the creators decide how their creations can be reused. To move to a user-driven ecosystem, the open movement started in the early 2000s. Central people in this movement were Richard Stallman and Lawrence Lessig. Stallman created a list of principles for free software which were incorporated into the open data movement. Lessig created the first set of open data licenses, the Creative Commons licenses. These two developments paved the way for open data licenses. These licenses are legal instruments that invert the logic of intellectual property. So creators provide pre-facto authorizations for reuse of their works to enable a remix culture, a culture where data and content can be freely used and reused. In this slide, we can see the key components of an open data licenses, which takes the form of a legal contract. First, it starts with a set of permissions that the creator grants, including the right to copy and the right to create derivatives. The creator can also add conditions like requiring credit or ensuring new works also remain open. Or the creator can use the public domain declaration to waive all ownership rights. There are many types of open data licenses. Creative Commons or the Open Database license are popular licenses for data sets. Countries like France and the United Kingdom also created their own licenses for open government datasets. In principle, open data licenses are a great tool to foster openness and create a user-driven open data ecosystem. But in practice, there are some practical and ethical challenges. We will now discuss some of these. One of the biggest practical challenges with open data licenses is uptake. Some laws, like the Open Data Directive in the European Union, encourage government bodies to release datasets under open licenses. But in other cases, use of open licenses is entirely voluntary and depends on the motivations of dataset creators. The other problem is choosing the right license. Currently, there are over 100 open data and content licenses available. And finally, once a license has been chosen, there is also the challenge of ensuring compliance by reusers. There are also ethical challenges. For instance, big data analytics come with the risk that personally identifiable data is either inadvertently included in an open data set or can be inferred from the data set. New technologies like generative AI also bring some challenges. Many models are trained on open data sets, but the outputs don't always respect license conditions of attribution and share alike. These create a tension between free reuse and responsible reuse of datasets. Creators need to make trade-offs between sharing more data for public good and in the public interest on the one hand, and balancing legal and ethical issues on the other hand. This is encapsulated in the principle of as open as possible, as closed as necessary. There are new license models for sharing data sets that might contain personal data. For example, two researchers have created the Open Data Commons license, which introduces a privacy pledge that must be affirmed by each reuser of a mixed data set. There are also new data sharing infrastructures that enable responsible sharing and reuse of personal data, such as the My Data project or Tim Berners-Lee's Solid project. When it comes to legal and ethical risks associated with new technologies, open data licenses can be combined with other legal obligations. For instance, the new AI Act, applicable to the European Union, imposes transparency obligations on developers of generative AI applications to disclose information about their training data. And finally, when it comes to compliance with license terms, we can look to case law developed by courts on open source licenses. You can see the names of some relevant cases on this slide. To recap what we discussed, an important aspect of opening data sets is ensuring legal openness. Open data licenses are the most common legal instrument to do so. But choosing the right license can be difficult. Here, the principle of as open as possible, as closed as necessary is useful. Further, for resolving new tensions with privacy, for example, data holders can look to emerging initiatives for collective licensing of personal data. And finally, open data licenses do not exist in a vacuum, but must work together with other legal obligations to ensure uptake as well as transparent data reuse. Thank you. Feel free to reach out for any questions.
A deep understanding of the user can make or break an open data ecosystem. That is why user experience research plays an important role in reducing uncertainty about user needs. In this video, we will explore how UX research can be applied within open data ecosystems. Let's introduce Nina. She leads a team responsible for designing a new open data platform. As a manager, Nina represents just one of many stakeholders in the open data ecosystem who can benefit from UX research. In turn, the Open Data Portal is just one of many digital products and services related to open data that can be analyzed. In the past, it was common for open data providers to launch projects without taking the time to study the users. As a result, the data release often failed to align with expectations or lack usability. Instead, Nina has decided to implement a user-driven open data portal. To accomplish this, she has deployed a UX research strategy. At the early stages of the product development cycle, generative research is conducted to answer fundamental questions about user needs, pain points, and desires. The insights obtained from this research are useful for guiding future product design and development. Nina has started in-depth interviews with key project stakeholders. This is an example of qualitative research technique. This type of research is key for uncovering the why behind people's actions, motivations, and problems. Examples of qualitative research techniques also include field studies, focus groups, and daily studies. Nina later turned to a survey to gather input from hundreds of potential portal users regarding the data sets they prioritize for the future site. Surveys are an example of a quantitative research technique. Other examples of quantitative methods include eye tracking, tree testing, and web analytics. Quantitative research is employed to collect and analyze numerical data, aiming to answer questions such as what, where, or when. Combining quantitative and qualitative methods in UX research provides a comprehensive view of user behavior by merging objective data with insights on user needs and motivations. Once a direction is selected, design and development start. During this phase, UX research methods are mostly employed to identify and address usability issues, guiding improvements as open data products or services evolve. Up to this point, the development team has produced a working prototype, and it has recruited a group of representative users. She has also designed a series of tasks for these users to perform on the prototype portal. The goal is to assess their experience, identify usability issues, and address them before the official launch. This technique is known as usability testing, and its application can substantially reduce the risk of product failure. Finally, the big day has arrived, and Nina and her team are celebrating the launch of a new user-driven open data portal. However, UX research doesn't stop there. After an open data service has been launched, it should be regularly evaluated to ensure it continues to meet expectations and to identify areas for improvement that will enhance its value over time. For this stage, Nina's team has incorporated a full set of web metrics into its platform. Web Analytics tracks and analyzes user interactions such as clicks and navigation paths. This data helps identify patterns in user behavior and highlights areas for improving the overall web experience. Taking advantage of UX research can be challenging. The vast amount of information it generates can be overwhelming, making it difficult to organize, prioritize, and clearly communicate your findings. But tools like user personas and journey maps can effectively summarize and communicate your main findings in an engaging way. As you can see, we have indirectly shown the application of these tools through Nina's case example. Now let's review the key lessons we have learned in this video. First, UX research methods can significantly contribute to the development of sustainable open data ecosystems. Second, the application of UX research is not confined to a single point in time. It's an ongoing process that influences all phases of the life cycle of open data products and services. Third, to maximize the benefits, it is useful to combine various qualitative and quantitative techniques, providing a holistic understanding of users and their needs. Finally, adopting UX research can be challenging. It requires time, effort, and commitment. It also may initially face resistance in organizations unfamiliar with this approach, but keep going. The benefits for the users are well worth the effort.
Hello. In this video, we will look into the importance of semantically interoperable data and how this can be achieved. Let's start. First of all, semantically interoperable data schema means that information between systems can automatically be exchanged by sharing common meaning. And this is achieved through universally accepted standards. But why is standardization important? Interoperability is one of the 4 principles of fair data: findable, accessible, interoperable, and reusable. In addition, the European Interoperability Framework defines technical, semantic, legal, and organizational as interoperability layers to successfully improve the quality of European digital public services. And for all this, standardization is key. Semantic interoperability can be improved using standardized and established data schemas, taking also into account existing vocabularies for domain-specific context. So, linking data schemas or parts of them with standardized ones is greatly beneficial for semantic interoperability. In addition, the use of controlled vocabularies, code lists, and standards is also critical to ensure consistent metadata, because metadata of good quality is key not only for interoperability but also data findability. The main challenge in the semantic interoperability landscape mostly comes from the inconsistent data vocabulary use or the use of non-standardized schemas. Many organizations and data provider groups use custom data or metadata schemas, which is problematic. So, how can linking data schemas improve the open data ecosystem and make it more user-driven? And in what ways can it enable users' interaction with open data? The role of ontologies and data models in search capabilities within large collections of data is critical. The integration of diverse data sources becomes feasible because ontologies frame the data conceptually and provide a common understanding of terms and their relationships. Large language models have been in the spotlight for undertaking the task of mapping common elements between different ontologies. The results of this process could systemically be integrated to provide recommendations on semantic mappings. So, given a custom metadata schema by the user or organization, a set of guidelines on how to make this schema or data semantically interoperable can be provided. Semantically interoperable data would mean connection with existing bodies of knowledge and data repositories, improved findability, and more relevant retrieval of results. Now let us consider an example in the cultural heritage domain. Supposing we have 2 art galleries, Gallery 1 and Gallery 2. Both art galleries have their own custom schema to describe their artifacts. For instance, Gallery 1 might name a painting art name, while Gallery 2 painting name. Also, the date of painting creation might be the field creation date in one and creation year in the other. Right now, data information across the galleries cannot flow seamlessly, although we understand that both refer to the same painting information but using different fields for it. A trained large language model on cultural heritage could identify those mappings and propose that they get replaced by fields of an existing standardized ontology of this domain. In this case, for example, SciDoc CRM is a comprehensive artifact representation schema, so the system or model could return a number of recommended links to this standardized one. So, in this case, galleries 1 and 2 would be semantically interoperable. More specifically, the general architecture of such a process could take the best of machine intelligence and human expertise, which is necessary for domain-specific context. It would work like this. First off, a large language model would be trained using expert-curated data to ensure accuracy of information. Then the model, for instance Llama, ChatGPT, GPT-4, or a combination, would propose mappings and links of various schemas to standardized vocabularies. Those vocabularies could be standard ontologies of the domain or recommended mappings from the linked open vocabularies repository. Human domain experts will validate those produced mappings, and this would be an iterative process until consensus is reached. This means the mappings would then be performed and possibly served as contributions to the linked open data cloud. The outcome of this process would be coherent data integration, as it would ensure all data is aligned with standard vocabularies of this domain, but also proximal domains, provided that relevant links are identified. Semantic interoperability seems to be drifting farther away from the notion of creating one ultimate ontology to represent all existing knowledge. Rather, the focus is on linking existing knowledge representation schemas to enable interoperability. Taking the best of human and machine understanding, it could be that we are entering a new technologically enabled era for semantic interoperability and the discoverability of data and datasets. With the help of technology, as described before, future data publishers can get strong recommendations on how to make their own data schema interoperable by creating necessary links between them and standardized ones. This would result in improved conceptual and hierarchical relationships for information representation. Also, the produced links and mappings among the different ontologies would be an active contributory process to the linked open data cloud.
Hello, today I'm going to talk about open data for social equity and inclusion in the public sector. And how can open data enhance inclusion from a public sector perspective? Today, we will explore the relationship between the public sector release and use of open data and the concept of inclusion, and we will address this question. But let's start by situating this topic. Albert Meyer highlights two main goals of open government policies, of which open data are part. The first one is vision, meaning transparency, and voice, allowing citizens to influence decisions. While open data also foster economic opportunities, this video focuses on vision and voice as they relate to inclusion in the public sector. And concerning the first goal, which is vision, Kyla Schroeder's study on New York's open data platform found that much of the data benefits the private sector more than the public. She emphasizes that governments must consider how open data can reflect or challenge power imbalances, ensuring they are relevant, contextualized, and foster meaningful civic engagement. Biases in open data can perpetuate stereotypes and inequities. For instance, a study published in Scientific Data on medical AI for decision-making revealed that it was trained on open data reflecting health disparities, leading to decisions that could reinforce existing inequalities. Data quality isn't just about metadata and structure, it should also capture human experiences accurately and fully. Principles like care for indigenous populations emphasize collaborative oversight in data collection, ensuring people are involved in decisions so that the data reflects their reality, promoting more inclusive and meaningful representation. Concerning the second goal, which is voice, it has been noted that not all citizens can engage equally due to varying levels of data literacy, which is the ability to critically interact with data. Additionally, the lack of feedback mechanisms like forums for questions can limit citizens' ability to interact with and take ownership of their data. Finally, social inequities persist, as scholars like Stefania Milan, Emanuele Terré, and Lynette Taylor highlight. digital infrastructure may seem inclusive but often excludes those lacking the ability to engage, such as migrants. This limits their interaction with data that impacts decisions and technologies affecting their lives. But how does this relate to inclusion in the public sector? Inclusion is increasingly being seen as essential, with public institutions expected to reduce inequities. This can be done by improving data relevancy, reducing bias, enhancing data quality, fostering data literacy, providing feedback mechanisms, and supporting those unable to engage with data. But let's make this more tangible. First, we can draw from some examples in literature in which open governmental data are used for identifying inequities. These inequities can be related to transportation, vaccination sites, or healthcare provision. This is an example of how relevant datasets can be used to achieve equitable outcomes. And public administration can promote inclusion by adopting strategies to collect open data relevant to citizens, such as equality data, which helps analyze and describe the state of equality. One example is the European Framework for Equality Data, which fosters participation of different stakeholders in the data collection. Open data are a crucial input for decision-making, especially in regulatory impact assessments. Governments use it to evaluate not only economic impacts, but also dimensions like gender and inequality. Therefore, it's vital that open data are inclusive, unbiased, and of high quality to ensure fair assessments. And from a theoretical perspective, the study of how the public sector can be inclusive in open data policies contributes to research on the broader topic of data justice, a growing strand of literature that investigates power imbalances connected to data. It also advances progress towards an equitable public administration. And in this video, we began by asking how can open data enhance inclusion from a public sector perspective? The answer lies in the fact that by focusing on inclusion, the public sector can promote equity, strengthen decision-making, and empower citizens. Open data helps shape better policies, provide leaders with tools to assess inclusivity, and amplifies voices, giving people a platform to express concerns and drive change. Ultimately, exploring this topic allows us to create social value. And thank you for listening.
Who can participate in open data ecosystems? Although open data is released to be freely used, modified, and shared, citizens without technical backgrounds, often called non-specialists, non-data experts, or lay audiences, face barriers associated with the complexity of handling the data and participating in open data processes. Citizens are often constrained to participate in open data ecosystems. Focusing on elementary school may help to bridge this gap and foster inclusiveness in open data ecosystems. In elementary school, students learn fundamental concepts and basic knowledge. Developing open data competences at an early age not only contributes to equipping them with necessary skills for a data-driven society, but also to fostering them as active citizens and potential contributors as important actors in open data ecosystems. And what are open data competences? In general terms, open data competences can be seen as the knowledge, skills, and abilities required to effectively engage in open data ecosystems. Participation can be achieved by adopting several roles, such as users, providers, or intermediaries. Data literacy and real-world problem solving have been identified as central for defining open data competences. Data literacy has been defined as the combination of technical and statistical skills with the ability to draw meaning by posing questions, interpreting and analyzing data, and creating visualizations. On the other hand, real-world problem solving has been defined as a dynamic analytical process used to address complex or ill-defined issues typically encountered in real-world environments. Open data competences in elementary school can be defined as a combination of data literacy, real-world problem solving, critical thinking, and open values, enabling young people to identify local problems, find relevant data to define and solve a problem, correlate arguments and data, analyze local open data visualizations, create hypotheses and alternative solutions to a problem, and deliver open data and data stories to the public. In this way, fostering students as users, providers, and intermediaries in open data ecosystems. How to develop open data competences in elementary school? Learning designs focus on how to achieve a learning goal, such as developing open data competences. The learning activity is at the center of learning designs, and interdependent elements such as the learners, other actors, the learning environment, and the learning outcome need to be considered. Finally, different learning theories create a framework for the design of learning activities. In the frame of doctorate research, a game-based learning design has been developed with the goal of developing open data competences. The Open Data Newsroom is a role-playing game that immerses 7th to 9th grade students in the analysis of local open data to solve a simulated environmental mystery. Students take the role of data journalists in a local newspaper to unravel mysterious incidents affecting the health of teenagers and the environment around the school. Physical and digital elements support the development of the game. In this video, you can see the digital platform that guides the game flow and supports pupils in the analysis of data visualizations. In the Open Data Newsroom, different game elements engage the pupils in an authentic data journalism practice based on 3 phases: getting, understanding, and delivering data. Pupils identify problems, analyze open data visualizations, correlate data and arguments to create data stories, and inform citizens in a simulated press conference. Conclusions and takeaways. For developing open data competences in elementary school, learning outcomes emphasize the ability to analyze real-world problems using open data and making stronger arguments based on data. This is essential in developing critical thinking and data analysis. The learning activity is centered on problems that relate to the students' interests and daily lives. Using local open data makes the learning experience more engaging. Finally, learning theories, such as authentic and game-based learning, drive learning designs that immerse students in authentic scenarios, where they can practice as real open data practitioners. Developing learning designs that integrate open data competences into young pupils' school education may enable them as open data users to solve real problems, provide open data about their local context, and intermediate between actors in their local open data ecosystems. Developing open data competences in schools cultivates a generation of open data literate citizens and fosters the inclusion of young people in current open data ecosystems.
Hello everyone. In this video we will talk about open data portals, and how an open data portal can be inclusive. Before diving into open data portals, let's first understand what open data means. Open data is publicly accessible information provided in a machine-readable format that can be freely used, shared, and modified by anyone without any restrictions. Now let's see what an open data portal is. An open data portal is an online platform that allows users to access, download, and use data freely. These portals are often maintained by the governments, non-government organizations, or institutions, and provide a central location for data that can be used for research, analysis, and decision making. Traditional open data portals often lack inclusiveness, failing to engage diverse user communities and address the needs of all stakeholders. Today, we will explore how embracing inclusiveness can transform these platforms into more effective tools for everyone. Let's understand inclusiveness by focusing on how different user groups can be better integrated into open government data portals. In this context, inclusiveness means ensuring that all stakeholders, from data publishers to end users, are considered and their unique needs addressed. Open government data portals aim to enhance transparency. However, their narrow focus often excluded key user groups, leading to underutilization. By promoting inclusiveness, we can ensure these open data portals serve a broader audience effectively. Several challenges undermine the effectiveness of open data portals, such as low user engagement, unaddressed technical needs, and inadequate feedback mechanisms, identifying and overcoming these challenges, which is crucial for improving data reuse and making the Open Data Portal more user-centric. So we must identify who are the open data actors, understand what are their technical needs, address potential conflicts of interest, and define the roles these actors from the perspective of governance and policymakers. Understanding the evolution of open data portals is crucial for identifying gaps and opportunities for improvements. By actively engaging stakeholders at every stage and making strategic, informed technical decisions, we can build more inclusive open data portals that truly meet the needs of all users. In the past, it was common for data publishers to just launch the data portals without first taking the time to understand their users and their needs. As a result, the data often failed to meet user expectations and lacked usability. Published research provides important insights into enhancing user engagement and thematic annotation. For example, the study identifying the evolution of open government data and their user engagement examines how social networks like X, formerly Twitter, can be consistently offer user feedback across various data initiatives. In a study titled as A Framework for the Thematic Annotation of Open Government Data proposes methods for automatic thematic classification to help users discover and filter resources more effectively. Open data portals, a feedback mechanism, refers to the process and tools that enable users to provide input on the data provided, such as its relevance, accuracy, and usability. Effective feedback mechanisms are crucial for building user expectations, trust, and ensuring the portal remains a valuable and responsive resource. Likewise, the research by Abdulaziz and Mohsen Ali identifies various feedback mechanisms aimed at bridging the gap between stakeholder needs and current feedback practices. These mechanisms are designed to capture user interaction and deliver actionable insights to enhance data quality and usability. Feedback is vital in refining data portals and ensuring they meet user needs. Effective feedback mechanisms allow data publishers to improve data quality and presentation, making the open data portals more valuable for all user groups. There are several types of feedback mechanisms that portal designers can implement, such as discussion forums, web forums, surveys, and digital feedback. Each has its own strengths and limitations in capturing user experiences and identifying users' areas for improvement. To design an effective feedback mechanism, it's essential to keep the process very simple and accessible. Feedback must also be actionable, meaning that portal administrators should be able to make improvements based on the user input. Now that we have covered the key elements of an inclusive open data portal, let's construct a conceptual framework that brings all the required elements together, providing a strategic approach to enhance inclusiveness in open data portals. It aligns user needs with the data portal functionalities to create a more user-friendly experience. To help portal designers, we have developed a simple and conceptual framework. First, engage users to provide feedback. Second, collect that feedback through various channels. Third, analyze the feedback for actionable insights. And finally, implement these changes to improve the portal. Societally, an inclusive open data ecosystem promotes greater accessibility and inclusivity, ensuring that all community members benefit from open data portals. Also, it provides policy recommendations to support this inclusive approach. In conclusion, inclusiveness is a complex construct, and our understanding of its application to open data portals remains limited. However, our research has shown that at least aspects like addressing technical challenges, enhancing user engagement, and incorporating feedback mechanisms can contribute to creating inclusive open data portals. And this way we can have an inclusive open data portals. Thank you so much.
This video explores how data physicalization fosters inclusiveness in open data ecosystems by enabling non-expert users to make meaningful data-driven decisions. But first, what is data physicalization? It involves the construction of a physical artifact whose geometry or material properties encode data, as initially defined by data visualization scholar Yvonne Janssen and her colleagues. By turning data into something we can see, touch, and interact with, data physicalization makes the information more relatable and visually appealing, engaging our senses in a more natural way. When we create physical representations of data, it not only helps with analysis, but also allows for exploration of new meanings and personal expression. This process lets individuals communicate ideas or insights that are hard to capture with numbers or traditional graphs. Let's look at a few examples. Loop is a physicalization of daily step count, which makes individuals aware of their activity data by changing its shape. By wearing a data badge that they made to a conference, participants express their personal interests and professional experience for others to see and connect over. This tangible map is an interactive, table-mounted, tactile and digital display that helps visitors explore the entire MIT University campus at a glance, and to even find out more information about specific buildings by touching them, which brings forth additional information about who works there and what kind of research they are doing. Apart from helping individuals explore data at their own pace and abilities, data physicalization can also bring multiple people together. Participatory data physicalization is a method used to invite multiple individuals to collaboratively contribute to a physical representation that embodies shared meaning in data. It is used in co-creation workshops, for public engagement, or even in action research, because it helps people to easily bring their different perspectives into alignment. By sharing their ideas, discussing their contributions, and finding common ground, they build a shared story based on the data that reflects everyone's input. Let's take a look at a few examples. In this workshop, several participants use colorful, squishy, and elastic candy to encode and then discuss productivity data among each other. In VoxBox, participants record their feelings about the conference they just attended through physical spinners and sliders. A local community attends a ritual where water pollution violations in their local river are being represented through lamps of different colors. People with little to no experience with data analysis learn how to collect data with sensors to then process it and interpret it collaboratively using Lego-inspired blocks. We saw from these few examples how non-experts who typically lack the skills to process and interpret complex data sets can use physical representations of data to make informed decisions about their lives. According to data feminist scholars Catherine D'Ignazio and Lauren Klein, this is especially important because marginalized and disadvantaged groups are often the ones most affected by the lack of meaningful access to data, which also applies to open data. Furthermore, the ability to critically interpret data in order to challenge systemic inequalities and further create more socially equitable narratives with data has been described as a necessity for all citizens in the digital democracy by data literacy scholars Lucy Pangrazio and Neil Selwyn. While data physicalization has been scientifically proved as an inclusive method for participation in data-driven decision-making, there are still some challenges to consider. One such challenge is the participants' ability to withdraw their consent to contribute to a physicalization. Individual contributions become anonymous as a result of group work, which means that their provenance can no longer be traced back to the actual participants who originally contributed it. This anonymization incapacitates individual participants to change, recontextualize, or even withdraw their contributions, even though they initially consented at the start of participatory data physicalization. Sustainability is another challenge of data physicalization. It is unclear what happens with the physical artifacts created through this method once they reach their end of life. Due to a lack of resources in the projects where they are developed and tensions about materials choices and the ownership of these artifacts, their creators are unable to consider sustainability in the process of planning, but also constructing physicalization. Moving forward, it will be essential to explore ways to preserve participant autonomy throughout the data physicalization process, ensuring that individuals can retain control over their contributions. Additionally, addressing the sustainability of physical artifacts by developing strategies for reuse, recycling, or repurposing will be key to making data physicalization both ethically and environmentally responsible. In this video, we discussed how data physicalization fosters inclusiveness by enabling non-expert users to make meaningful data-driven decisions. From a societal perspective, the use of data physicalization helps to support individuals to create new meanings from existing datasets, which from a participatory perspective helps the public and communities to address issues of their concern. From a scientific perspective, we discussed how data physicalization can be used as a method to increase data literacy among non-expert users, many from systemically disadvantaged groups, while also considering the challenges of participant consent and sustainability. As we move forward, it is crucial that we continue to explore how data physicalization can empower individuals and communities, especially those who have been historically excluded from data-driven decision-making, which is the main tenet of open data. Whether you are a scientist, you represent a non-profit organization, or you are an educator, by incorporating data physicalization into your toolbox, you can contribute to the sustainability of open data ecosystems.
Open data does not yield any automatic benefits. It is only beneficial when someone discovers it and reuses it. Open data hackathons are one of the approaches used by governments, NPOs, as well as the private sector to show the availability of open datasets and to encourage the public to brainstorm new applications for them. The term hackathon stands for Hacking Marathon. While hackathon outcomes are rarely implemented or sustained after the event, there are still important benefits, such as collaborative learning, networking and community building, and the discovery of open datasets. From the perspective of inclusiveness, however, open data hackathons are often designed for a technical, specialist audience, such as data scientists and programmers. I want to talk about some considerations to include a wider audience in open data hackathons. Let's start by talking about what to do before the hackathon. Potential hackathon participants might worry that the event is not intended for people with low technical skills, that during the event they will not find people with a similar background, that they do not have the specific skills needed to make a meaningful contribution, or that they just won't have time to attend. To address these concerns, open data hackathons organizers should convincingly show that their event welcomes non-specialist users. For example, by showing statistics about previous participants, such as their gender distribution and backgrounds. Advertisement materials should also show possible tasks that non-technical users can perform. Let's now talk about what to do during the event, starting with the introductory presentation to participants. There are 3 key points to stress. First, avoiding a 24/7 working culture. The time pressure and competitive environment might push some participants to spend long hours working on their prototype. In your opening presentation, remind them that they are not expected to do so. Consider including regular breaks in the agenda and, if the event is more than 1 day long, consider closing the venue in the evening. Second, stress that technicality is not a priority. Show real examples of prototypes made with simple materials. Remind participants that it is enough to sketch their prototype on a piece of paper and that it is not necessary to make complex prototypes. Third, establish a code of conduct for hackathon participants and include rules about respectful behavior and inclusiveness. Coming to the actual activities of the hackathon, keep in mind that highly technical tools exclude some participants. You can suggest or even mandate that participants use beginner-friendly tools. There is an abundance of low-code or no-code development and data analysis tools. Also, when working with open data, try to provide participants with datasets that have already been cleaned. One of the most important parts of a hackathon is deciding which team to join. Having a good team working on an interesting idea can make all the difference. Keep in mind that participants might find it safer to stick with people they already know or who have similar skills. This could lead to very homogeneous teams. To encourage people to form interdisciplinary teams, you need to have an appropriate group forming process. In the capitalist process, participants are free to pitch an idea and anyone can freely join their group. The socialist process is more focused on people and is all about getting to know as many hackathon participants as possible before picking a team. You can read more detailed instructions at the link included at the end of this presentation. Consider mandating a specific team size so that at least some participants will need to mix. Teams of 4 to 5 people usually work well. Also consider asking participants to create a name tag showing the skills they already possess so that it is easier to form interdisciplinary teams. Now let's talk about what happens after the hackathon. After the event, it is important to collect data to assess whether the hackathon was in fact inclusive. One of the simplest ways to do this is to distribute a survey containing items on participant demographics, their satisfaction with the event, feeling of inclusion, and willingness to participate again in the future. Please remember that if you collect personal data, GDPR applies. If you're organizing a hackathon for research purposes, you might also need to seek the approval of an ethics committee. If possible, consider conducting a focus group interview with some participants to inquire about the group dynamics and roles and responsibilities that they took during the event. We looked at some things to keep in mind as an Open Data Hackathon organizer before, during, and after the event. Open Data Hackathons are important community building opportunities. Ensuring that non-specialist users feel welcome is a practical step towards more inclusive open data ecosystems.
Hello, in this video, I will talk about how open data intermediaries can improve the circularity of open data ecosystem. What does circularity mean in the context of open data ecosystem? Circularity means that all open data ecosystem actors should simultaneously create and capture value. There are various types of values, such as financial, political, and societal values. Actors who create value in the open data ecosystem, such as public organizations that publish open data, should also be able to get value back, such as in terms of financial compensation, new insights for policy planning, or augmented data. Likewise, actors who capture value from the open data ecosystem, such as companies that develop products based on open data, should also give value back to the ecosystem. This applies to all other types of actors apart from public organizations and companies. According to Van Lunen and co-authors, in a sustainable open data ecosystem, value should circulate among different actors. In other words, everyone should give and take at the same time. Actors should not only capture value from the ecosystem without giving anything substantially in return, and vice versa. In this video, we focus on the role of open data intermediaries in improving the circularity of the open data ecosystem. Before going deeper, let's see what are open data intermediaries. Open data intermediaries are defined as third-party actors who provide specialized resources and capabilities to enhance the supply flow and/or use of open data and/or strengthen the relationships among various open data stakeholders. Examples of open data intermediaries are software developers that include pre-processed open data in their software, open data platforms that allow people to contribute and use open data, and media organizations that produce journalistic reports through analyzing open data and adding context. As an example, we will look at how a geospatial software company contributes to the circularity of the open data ecosystem through its role as an open data intermediary. This is based on a case study we conducted. The company offers software packages for geospatial practitioners such as city planners, engineers, disaster response organizations, and researchers to create, analyze, and disseminate digital maps. To improve the user experience with its software, the company obtains, pre-processes, and integrates open data from various sources into the software. This improves the reusability of open data for its software users. At the same time, the company also improves the appeal and sales of its software and consequently generates more income. This is an example of how the company creates and captures value simultaneously. But does the company also facilitate its software users to create value instead of only capturing value through reusing open data themselves? To some extent, yes. The software facilitates its users to produce and disseminate interactive visualizations or applications that others, especially those with limited technical backgrounds, can use to explore data and generate insights. At the same time, the company also contributes value to open data providers to some extent. Based on the insights it obtains from its software users, the company advises open data providers on how to improve their open data dissemination. The company also raises public awareness of the value of open data and indirectly encourages support to open data providers, for example, in terms of funding, so that open data providers can continue offering open data. Hence, in this scenario, open data providers also benefit from the company's open data intermediation role. There are other ways where open data intermediaries can play a role in improving the circularity of the open data ecosystem. For example, open data intermediaries can foster public-private, public-civic, or multi-stakeholder collaborations. For instance, they may facilitate collaborations in which the public, private, and civil sectors pool resources and jointly coordinate efforts to build and maintain technical infrastructure to publish open data. Open data intermediaries may also help streamline cross-administrative data management processes. For example, they may consult different open data providers on appropriate data standards and licenses that facilitate the integration of open data from various sources. Open data intermediaries may also facilitate the flow of augmented open data back to open data providers. There are, of course, other potential contributions of open data intermediaries to improve the circularity of the open data ecosystem, apart from the examples here. For open data intermediaries to contribute towards the circularity of the open data ecosystem, they require internal incentives, such as viable business models, where they can capture value for themselves while contributing value to other open data actors. They may also require external incentives, such as policies and regulations that compel them to contribute back to the open data ecosystem in certain ways. Therefore, continued research and development in the design of business models and policy interventions for open data intermediaries is necessary. In conclusion, in this video, we have demonstrated open data intermediaries can improve the circularity of the open data ecosystem. There are various potential ways in which they can do so. Nevertheless, the design of internal and external incentives in terms of business models and policy interventions are necessary to direct open data intermediaries' contributions towards the circularity of the open data ecosystem. If you want to know more on this topic, here are some of the references.
In this talk, I'll be discussing an innovative approach to fostering circularity in open data portals. Particularly, we'll look at how artificial intelligence and collective intelligence can generate improved metadata for datasets. We use European Data Portal as our case study. Circularity in open data refers to the continuous cycle of data generation, sharing, utilization, and improvement. It's about ensuring that the open data is not just created and forgotten. It is constantly enriched, shared, and reused to maximize its value across different sectors and stakeholders. In the open data ecosystem, governments, businesses, and other stakeholders create and share open data. The public and businesses then use and reuse that open data, providing feedback for improvement. This feedback leads to modifications or the creation of improved data by governments and businesses. To realize our study, we considered the European Data Portal as a use case to gauge the potential of AI in enhancing circularity in open data portals. We analyzed 37,306 datasets from the European Data Portal, and 32% of them had 3 or fewer keywords. A significant amount of other datasets also had non-representative traits and discrepancies. Upon examination of themes, we found that they followed similar traits as well, while a whole lot of descriptions were generic too. According to European Data Portal, keywords and themes contribute the most to a dataset's findability and discoverability. They are mostly extracted from descriptions, which makes them equally important as well. In essence, the metadata elements such as keywords and themes play a crucial role in the findability of datasets. To address this challenge, AI and CI have the potential to play a significant role in enhancing data discoverability, as you can see in the proposed circular framework. This proposed framework uses artificial intelligence and collective intelligence to enhance metadata quality, making it easier to find and reuse datasets. It starts with the publisher uploading the dataset to the portal in conventional data formats such as CSV. The trained large language model deployed with the portal then reads the dataset, generates metadata for it, and then the portal displays it to the publisher. The publisher then analyzes it and either improves or leaves it as it is. Then the publisher finally submits the data to the portal and it is stored. Eventually, after a particular threshold of time, LLM is retrained on the data improved by the publisher to make its output more fitting to publishers' needs. Using AI and CI to enhance metadata brings several significant benefits that promote circularity in data. For instance, improved data discovery ensures that datasets are easier to find and access even for less experienced users. Enhanced data quality allows the ecosystem to continuously improve metadata accuracy. It ensures that open data remains valuable, up-to-date, and usable across different sectors. Another key benefit is increased open data reuse. With better metadata, datasets become more accessible and understandable, encouraging their use in various domains like healthcare and research. Finally, greater collaboration is fostered by standardized and enriched metadata. It makes it easier for all the stakeholders to share, combine, and build on each other's work, enhancing the overall ecosystem. In this lecture, we set out to explore how artificial intelligence and collective intelligence can be harnessed to foster circularity in open data portals. Our objective was to demonstrate how using AI and CI, we can create a more enriched open data ecosystem, making datasets more discoverable, accessible, and reusable. Through the proposed AI for CI for AI framework, we showed how AI assists users by generating metadata. Also, on the other hand, how users enhance the AI model through their feedback. It leads to a continuous circular loop by integrating hubs with hubs, portals with portals, and AI models with other models. We have laid the groundwork for a truly interconnected circular open data ecosystem. This approach not only achieves our objective, but also paves the way for a future where humans and AI collaborate seamlessly. The vision of a connected circular open data ecosystem is within our reach, but it will take all of us working together to make it happen. Let's embark on this journey of collaboration together and turn this vision into a reality.
Hi, today we will discuss how to foster circularity within open data ecosystems by aligning private values to data and value contribution. But first, we have to define circularity. In a linear open data ecosystem, producers create value, which users then capture. Meanwhile, in a circular ecosystem, all actors are able to capture and create value simultaneously. Our first question to answer is, who are the users of open data? Users can be separated into citizens, governments, non-profit organizations, and commercial organizations, each of them having different needs. The current open data paradigm can be defined as linear, with no feedback mechanisms. Therefore, the question to foster circularity would be, how can users of open data not only utilize value, but also contribute back to the ecosystem? We will look at a case study to understand the topic with an example of how users of open data deliver back to the ecosystem. OpenStreetMap is the most extensive crowdsourced geographical database of the world. It all started with volunteer individuals who contributed data by surveying their local area. As time passed, it became a global movement, with contributions from all corners, effectively creating a more diverse and detailed geographical representation of our world. In recent years, edits from organizational actors have gained more traction, with non-profit organizations, especially in the humanitarian realm, governments, and for-profit corporations, contributing to a map that goes beyond local knowledge. This diversity is also reflected in an ecosystem of tools built around the database, catering to everything from personalized map visualization and routing to data contribution. This is also complemented by an ecosystem of communities, each with its goals, area covered, and work domain, effectively making OpenStreetMap impact go beyond a simple database. We interviewed 25 for-profit companies that contribute to OpenStreetMap, asking how and why they contribute. The result was a mixture of home private values and social public values. The most mentioned motivation overall is to improve the data quality. Companies use OpenStreetMap to enrich the services they offer to their clients. It is therefore in the company's best interest to improve OpenStreetMap's data and keep it of high quality. Another greatly mentioned private value motivation, which relates to the previous one, is to align with one's own dataset. The second most mentioned motivation overall is to build a community. Communities of mappers are essential to maintaining data sustainability in the OpenStreetMap project. Companies help by setting up events with local communities or kickstarting communities within the company's domain. Finally, being grateful and wanting to give back are motivations mentioned by several interviewees too. OpenStreetMap creates a space where companies' contributions can benefit their business models, while at the same time creating value and benefiting the whole ecosystem. Different users have different needs and goals. In the case of companies, one of their goals is to give good quality services to their clients. Aligning them to data contribution can enable a circular ecosystem, leaving behind the linear paradigm. In the case of OpenStreetMap, companies are not only users of the data, but also contribute to it. This ensures good quality data for the company's services and keeps OpenStreetMap's open data improved and its communities more engaged, making it a win-win situation. Finally, other users of the platform can also benefit from the engagement created and see the potential in aligning their own needs and goals to ensure project sustainability.
This video is about the role of journalists in the open data ecosystem. The discovery and publication of facts are at the heart of journalism, but the deliberate and structured use of data to support them, known as data journalism, has its origins in the 19th century. Notable examples include the Manchester Guardian's 1821 report on schools, which presented students' data in a table format, and Florence Nightingale's statistical charts that visualized mortality rates during the Crimean War. Digitalization of our society has provided journalists with more ways to access and analyze data. However, it is the rise of open data in the past few decades that has truly revolutionized the field, giving journalists unprecedented access to vast amounts of information to analyze and report on. This abundance of accessible data has transformed journalistic practices, enabling a more comprehensive and data-driven storytelling. Let's examine the key role that journalists can play in the open data ecosystem and how they can improve its circularity, where by circularity we mean the continuous feedback process that incorporates the generation, dissemination, application, and improvement of open data. Data journalists play a key role in the open data ecosystem, acting as crucial intermediaries between raw data and public understanding. Through the use of open data, they can enhance their traditional roles as communicators and transparency advocates, but they can also work as open data intermediaries and producers. Furthermore, they act as catalysts for the public to be exposed to and eventually engage in the open data ecosystem. Using open data, journalists enhance their traditional role as communicators by translating complex open data into accessible narratives, bridging the gap between raw information and public understanding. A good example of this journalistic approach is the stories that were published during the 2016 and 2017 winter period about the problems UK hospitals faced in meeting the 4-hour waiting target for patients in emergency rooms. These articles interpreted open data from hospitals into accessible stories that could explain the issues citizens were facing at the time. This function is particularly important as our world is becoming more complex and increasingly reliant on data. By combining data analysis with storytelling techniques, they transform raw information into relatable and impactful stories. To achieve this, journalists employed a wide range of infographic types to visually communicate open data insights. These visual representations help simplify complex information and make it more accessible to readers. This approach also allows journalists to present evidence-based insights while maintaining audience engagement. Another role that is integrated into the journalistic profession is the accountability aspect. Journalists can conduct in-depth investigations exposing potential misconduct or inefficiencies in governments and corporations. For example, the investigation into the Salmonella outbreak in the US conducted by ProPublica used data from several sources to investigate into the incidents and revealed several flaws into the food safety system. By analyzing and interpreting complex datasets, they uncover patterns, discrepancies, and trends that might otherwise remain hidden from the public. This data-driven approach enabled journalists to present compelling evidence-based reports that hold powerful entities accountable and inform the public about critical issues affecting their lives. Most importantly, this function of journalism, which can be enhanced by the use of open data, as they are readily available and easily accessible, allows them to transform their stories from opinions and demonstrations of public sentiment to data-based critiques. This aligns perfectly with one of the core values of open data, promoting transparency and accountability in society. Journalists can play a more direct role in enhancing the circularity of the open data ecosystem. By presenting data in their stories, journalists enable readers to explore the raw information behind the reporting. This practice enhances transparency and allows audience to draw their own insights from the presented information. By cleaning, analyzing, and compiling information from various sources, journalists create unique datasets that shed light on important issues. These journalist-created datasets can become valuable resources for further reporting, academic research, and public understanding of complex topics. Journalists can also enhance existing datasets by combining multiple sources, as demonstrated in the case of Charlottesville housing crisis, where data from the Census, Bureau of Labor Statistics, ALICE Project, and Charlottesville Open Data Portal were integrated to provide a more comprehensive view of housing affordability issues. By using open data for the reporting, journalists can act as evaluators of the data quality of open datasets, detecting discrepancies, inconsistencies, and gaps. Through their unique position in society as public watchdogs, they can directly contact data providers and apply pressure to improve the data that are published. Perhaps the most important role that journalists can have is that of a catalyst for greater public involvement in the open data ecosystem. Journalists demonstrate the power of open data in addressing real-world problems, crafting stories that highlight successful applications of open data in various sectors, such as healthcare, education, or urban planning, effectively showcases the potential of open data to improve lives and communities. These impactful stories can motivate readers to explore and utilize these resources themselves. This can increase public engagement with open data, cultivate a more informed and participatory society, and enable citizens to make data-driven decisions. In conclusion, journalists not only make the insights of open data accessible to the public through their investigations, but they also contribute to the enrichment of the open data ecosystem with the release of their own datasets as open data. For example, The Guardian has a data blog where they maintain a collection of datasets. Similarly, Deutsche Welle and Politico, although they publish mostly open source tools on their GitHub repositories, they also include some datasets that they have used in their reporting. Journalists also play a crucial role as data quality evaluators. Through the use of open data, they enhance their traditional roles as guardians of transparency society. Moreover, they presenting relatable examples of open data usage that they can inspire citizens to become directly involved in the open data ecosystem. All this highlights the importance of journalism in maintaining a vibrant, effective, and circular open data ecosystem that serves the needs of a democratic society by keeping citizens informed and transforming them into active participants both in society and the open data ecosystem.
Hi, in this video I will talk about evaluating the use of local governments' open data in open data ecosystems. The potential of open data to achieve transparency, efficiency, innovation, and citizen participation has been widely promoted. But what if the way open data is currently used actually discourages engagement in the open data ecosystem? Currently, there is an unequal value distribution in how open data is used, where only a few stakeholders benefit from open data. A circular open data ecosystem can change this by ensuring all the ecosystem participants contribute and benefit from the value created. To realize this vision, we must thoroughly evaluate the open data utilization process. Evaluating the use of open data in open data ecosystems is far from simple. The interrelationships involved are intricate, the outcomes are indirect, and use cases can vary widely. Difficulties range from data quality issues to the challenge of measuring non-economic benefits. In recent years, the focus has shifted from measuring the impact of open data to defining and measuring its value. This change opens up new ways to measure data, emphasizing its value and how it is used to create value. Evaluating the use of open data released by local governments such as Copenhagen or Rotterdam municipality becomes particularly relevant. Local governments are responsible for managing their community services, infrastructure, and policies, making them crucial in making data actionable for citizens. However, they often operate within smaller resource-constrained environments, making it hard to standardize, track, and attribute open data's broader societal and economic effects compared to the national-level initiative. A systemic purpose-driven approach can help address these challenges, offering a way to evaluate impact beyond isolated user assessments. According to systemic design theory, defining the ecosystem's boundaries is crucial to understanding its interconnectedness. These boundaries aren't fixed. They shift depending on the perspective, participants, and objectives. We use a systemic design theory and a purpose-driven approach to study the use of open data from local governments within open data ecosystems. We created a framework by analyzing existing literature that describes the local use of open government data. We then refined this framework by applying it to 7 use cases from Denmark. The framework highlights the underlying purposes and interrelationships in using local government data, providing a tool for evaluating open data in these ecosystems. The framework, inspired by the work of Capra and Lucy, comprehends the intended purposes of using open data through its material embodiments and underlying meanings. It also examines interrelationships in using local government open data from operational, technological, strategic, accountability, regulatory, and ethical dimensions across 3 stages of data use: obtaining, transforming, and sustaining. To illustrate the framework, let's consider a use case in Denmark. Local governments provide open geographical data to create an online public platform managed by the Danish Nature Agency to promote outdoor recreational activities. The purpose of using this data can be understood using the developed framework through its material embodiments and intended meanings. The material embodiments include the actual infrastructure the data represents, a comprehensive outdoor facilities database, the open government data repository where the information is stored, and the online public platform. The framework identifies 3 kinds of intended meanings: solution-driven, collaboration-driven, and knowledge-driven. In the case of the Danish Nature Agency, solution-driven meanings involve efficient facility management for local authorities, enhanced trip planning for outdoor explorers, and promoting outdoor activities including fitness, education, and even rehabilitation programs. Collaboration-driven meanings entail cooperation between organizations such as the Danish Nature Agency, local governments, and the Open Government Data Repository team. It also aims to facilitate cross-platform data use and foster community engagement. Knowledge-driven meanings involve influencing policies and funding allocations based on the increased use of green spaces and community needs. The framework also emphasizes the interrelationships within the ecosystem as open data progresses through the stages of obtaining, transforming, and sustaining. Let's discuss each of these stages in their corresponding interrelations. During the obtaining stage, operational interrelations involve collaboration between the online public platform team and local governments to ensure data accuracy. The actors involved work together to centralize data storage and align the strategic vision to a data-born online public platform. Additionally, different teams collaborate to collect and process data within local governments to enhance their capabilities while ensuring responsible management and use of the data through accountability, regulations, and ethical considerations. As the open data progresses to the transformation stage, the focus shifts to analyzing, disseminating, and interpreting data. In the case of the Danish Nature Agency, geographic information system tools are used to enhance data usability, and partnerships between local governments and private organizations aim to disseminate and visualize the open data effectively. In the sustainment stage, Maintaining the data's accuracy and relevance is the focus. In the case of the Danish Nature Agency, mechanisms like annual updates ensure that the data remains current, and ethical considerations ensure that it serves diverse communities, such as people with disabilities. This framework offers a tool for evaluating local governments' open data use within open data ecosystems. By understanding the different stages of data use and identifying the complex interrelationships involved, policymakers, practitioners, and researchers can better understand the challenges across various dimensions, overlapping impacts and timeframes. This can help design strategies that improve use. Further research is needed to validate the framework.